All right, welcome to composite functions. Remember, composite functions, it's function composition. That's functions inside of functions. So it's going to look like we're going to be doing stuff like this. Stuff like this. Sine inverse is inside of a sine function. And then we're going to start with some simpler ones on this video, and then some more complicated, aka more fun ones in the next video. All right. So normally, right, when we're talking about inverse functions, right, f inverse of x is just equal to x, right, and vice versa. So normally when we compose functions with each other, normally when we compose functions with their inverses, they cancel each other out and we're just left with the inside. But remember that we did restrict our domains, right? Go all the way back here. They're only going to cancel for us when the angles are in these domains of sine, when these angles are in these ranges of arc sine. Okay. And that corresponds to what we have over here. And then I said, if theta is outside these angles, we got some weird stuff. Well, it is weird stuff o'clock. Oh, things to not say to your class. All right. Let's get going. Okay, so there's two methods of evaluating things like this. We'll use them both. And you can choose which one you like better. Okay, and you're going to have to do a lot of these by hand if you want an exact answer. And I will be requesting exact answers for a lot of things, so watch out. Example 4. I think that's what we're on. Evaluate exactly. Part A. The inverse sine of the sine of pi over 3. So there's two methods. I mentioned there's two methods. I should comment on what they are. So the first method is just going to be order of operations. Right? Let's just evaluate what sine of pi over 3 is, and then take the arc sine like we did in the last video. All right? The other method, which we'll denote in blue, is going to be using reference angles. That's like a double E. Reference angles. So let's show both. So if we do order of operations, we say, okay, well, let's just start on the inside. Parentheses, PEMDAS. Parentheses is the first thing. Let's start on the middle. What is the sine of pi over 3? Let's look to our special triangles, wherever they are. How far do I have to go to find pi over 3? What's the sine? Opposite of pi over 3 divided by hypotenuse. That cancels to root 3 over 2. All right, and then we have to say, well, what is arc sine of root 3 over 2? Arc sine of root 3 over 2? Well, what angle has root 3 over 2? Well, we just answered that. Angle is pi over 3. So this is the straightforward bang your head into a wall method. There's not a lot of finesse. Just doing things one thing at a time. So this is one of those rare occasions, right? Pi over 3 is in that restricted domain. So that's why they essentially just canceled and we were left with pi over 3. Because pi over 3, oops, excuse me. Oh, I didn't want to keep that. I wanted to undo that, but once I switched, I can't undo it anymore. Pi over 3 is in that restricted domain. Pi over 3 for sine is in that restricted domain. So we have this really nice property. All right, let's do it the other way. Reference angles says find the reference angle in the domain in that restricted domain. And that's our answer basically. Or not technically reference angles always. Maybe that's a bad way to summarize it. It's useful for memory, but Let's look at the other one. So the other method says, okay, pi over 3 is in the restricted domain. So we're done. So sine inverse, sine of pi over 3. They cancel each other out. And we're just left with pi over 3. If pi over 3 wasn't in the restricted domain, this would be harder. But that's kind of what we're doing here. And they cancel out. And again, they don't actually, with this method, we shouldn't be writing it that way. I wanted to erase those red marks. So that's how I erase the red marks. If it's in the restricted domain, then yes, they exactly cancel like that. Okay, so that's example A, both methods. Let's do another example and show both methods. Let's do something that's not in the restricted domain and see what happens. Okay, part B is going to be, I have no idea where I am on my notes, arcsine of the sine of 2 pi over 3. So two ways. We can directly evaluate, or we can look at, let's rename this. Look at the restricted domain or something. Use domain restrictions. The name is not important, really, but it's helpful. Names are helpful. What if I just never told you my name for the whole quarter? And then on the college website, it doesn't have my name. It just says mysterious professor, ? And he just couldn't call me anything the whole quarter. Anyway, what am I talking about? So if we evaluated this directly, we'd have to look at the sine of 2 pi over 3. Ooh, this is a bit of a throwback. 2 pi over 3, what is that angle? That's pi over, and then subtract pi over 3. As a reference angle of pi over 3. Right, this is 2 pi over 3. And as a reference angle of pi over 3. So to find the sine here, we look at the sine of that reference angle. We look at the sine of pi over 3. And then use all squids train camels. Always save the cats. To figure out whether it's positive or not. So we know the sine of pi over 3 is root 3 over 2. So it's going to be root 3 over 2. Sine's positive in the second quadrant, so it's positive root 3 over 2. Now we have to evaluate arcsine of root 3 over 2. The sine of what angle gives us root 3 over 2? That's that earlier video, 8.3.2. How do we get root 3 over 2? With an angle of pi over 3. So this equals pi over 3. Pi over 3 is in the range of arcsine. That's important. And a positive pi over 3 gives a positive angle. So that's how we know we're right. And again, for all of these, we can be checking our answers. Okay? Our calculator is going to give us a decimal approximation, but that's okay. Just like we did it before. All right, if I want to know the arcsine of the sine of 2 pi over 3, it should equal that. Well, what does that equal to? Hopefully that's pi over 3. So you can check, yes, that is pi over 3. Check your answer with a calculator like this. All right. I will be needing you to show your work on some of these problems, so make sure to show you the steps that I'm showing here. But again, the other way is to say, okay, is 2 pi over 3 in the range? And no. All right, so if we go over to the side and use that second method, we'd also get that 2 pi over 3 is right here. It has a reference angle of pi over 3. So we're going to use that reference angle to give us that pi over 3. So it almost cancels out with the blue method. If we use the blue method up here, we're going to say, okay, there's a reference angle of pi over 3. And then pi over 3 is in the range of arcsine and gives a positive Okay, so just like 2 pi over 3. So you just have to make sure that it has the same like sign, S-I-G-N, positive or negative, as that other thing. And so this blue method is just a little less straightforward, I think. Like we can use it, but I think the red method is probably what I would recommend most of the time, just because it is so straightforward. You always do the same thing every single time, whereas the blue kind of depends on a couple different cases. All right, let's do 2 more. Just give extra examples. Part C, going to be the cosine inverse of cosine of 2 pi over 3. So again, blue method is actually really nice here because 2 pi over 3 is in that restricted domain. For cosine, 2 pi over 3 is in that restricted domain. If it's in the restricted domain, blue method is really simple. Blue method says, oh, in restricted domain, they cancel perfectly. Inverse cosine and cosine, inverse functions, because we're in the restricted domain. But red method also works, right? Inverse cosine. What's the cosine of 60 degrees? It's 1/2, and it's positive because it's in the first quadrant, and everything's positive in the first quadrant for trig functions. What's the inverse cosine? Well, what angle is going to give us 1/2? Well, we think it's going to be pi over 3. Pi over 3 is going to give us a positive ratio. Yep, we want a positive ratio. So yep, inverse cosine of 1/2 is going to be pi over 3 using the red method is really just using the method from the earlier videos in this section. All right. Oh, my word. Oh, no. Look what I did. There's 2 big mistakes here. Well, really 1 big mistake. These should be the same, right? Cosine of 2 pi over 3 is not positive 1/2, right? Cosine of 2 pi over 3, oh no, that's in the second quadrant. All squids train camels. Cosine's negative here. So cosine's negative right here. So again, we think pi over 3 because that's how we get 1/2, but we need it to be negative. So to evaluate inverse cosine, it has to be something in this interval, in the first or the second quadrant. So we need something in the second quadrant with a reference angle of pi over 3. That's going to be 2 pi over 3. So arc cosine of negative 1/2 is actually 2 pi over 3 because that's what it takes to get that negative up there. Whew! That's why checking your answer is a good idea, even if you're a math professor. It's actually really nice in a real class because you do something stupid that you don't notice. A student will be like, can you explain to me how that's pi over 3? And you're like, there's no explanation. It's just wrong. But I think, thanks for being polite. Is usually what happens. I appreciate all of you. Unfortunately, you're in the future right now. I'm in the past. Arc cosine of the cosine of negative pi over 3. So this is not, right? This is not in the restricted domain. Right? Restricted domain was 0 to pi for cosine. This is not in that. All right, so blue method's a little bit more complicated here. Red method still works. Do things one at a time. What is the cosine of negative pi over 3? Well, negative pi over 3 is in the fourth quadrant. Is a reference angle of pi over 3. And all squids train camels. It's going to be positive. So we look at the cosine of pi over 3, which is again 1/2. And it's in the fourth quadrant, so it's positive. So now we just need to find, okay, what angle gives us 1/2? Well, we've already kind of mentioned it. It's pi over 3. Is pi over 3 in the restricted domain? Yes. Does it give it positive? Yes. then arc cosine of 1/2 is just pi over 3. You can check that with the calculator. It'll check out. All right, or likewise, you could say, all right, so it's not in the restricted domain. What angle in the restricted domain gives us the same values? So restricted domain is going to be one of these two. We need it to be the same sign as down here. So first, so we look at, okay, cosine, right, is positive in the fourth quadrant. So we choose quadrant 1 in the restricted domain to match that. If we had something in the third quadrant, we'd choose quadrant 2 in the restricted domain. All right, so it's just, okay, what quadrant or what angle in quadrant 1 has the same reference angle? All right, and the answer is pi over 3. Again, blue method really just kind of only shines when you are in the restricted domain. And again, we could, let's just check this answer. Arc cosine of the cosine of, what was it, negative pi over 3 is pi over 3. There we go. Those two numbers match. We're good to go. That's how you check your answers, and that's how you do composite functions of this specific form. Composite functions of other forms, ooh, they're coming in the next one. All right, enjoy.